Hello, my name is Christopher Thrawn. I'm Associate Professor of Mathematics at Texas A&M University, Central Texas, and I'm going to talk to you today about machine learning for real-world applications. All right, so let's get started. Notice my email at the bottom, thrawn@tamuct.edu. All right, so in this talk I will give a high-level overview of the issues involved with machine learning in practice. Number two, what is necessary to apply machine learning to a practical problem? And in the slides I will use ML to abbreviate machine learning. So next, some examples of master's level machine learning research. Next, some professional opportunities in machine learning. And finally, resources from the internet to go further in depth. So what is machine learning? Machine learning generates functions. Now, a function is a mathematical construction with inputs and outputs. So machine learning always generates a computational structure with inputs and outputs. And the functions are used to classify, cluster, or predict data using computationally intensive methods applied to sample data. In this way, machine learning is similar to statistics. Basic statistical regression is also used to predict data, but the methods used are not computationally intensive. Machine learning uses computationally intensive methods that cannot be done by hand, but must be done by computer. Two types of machine learning: supervised machine learning. Supervised machine learning creates functions using training data and verifies with testing data. And I'll give examples shortly. Unsupervised machine learning organizes data to make it more comprehensible and usable. Unsupervised machine learning does not require training and test data, but does require some data to characterize. I'll show you in a moment. Right. So here's an example of machine learning. Suppose I want to distinguish between two different categories. For instance, two different types of bird. Each type of bird, each individual bird has a width, has a weight and a length. As you can see on the right here, we have a graph with weight versus length. Now, each point on this graph is a bird. Each individual bird has a width, weight, and a height that I can plot on this graph. The red points correspond to one type of bird, and the blue points correspond to another type of bird. Now, you can see there are smaller dots and also larger dots, and the larger dots correspond to samples that I have available. And the smaller dots correspond to birds that are in the population that are not available. So the large dots, both blue and red, correspond to available bird data, while the small dots correspond to data, as I said, that is not available. So using the data corresponding to the large dots, I will try to create a boundary, and you can see the boundary is the purple line in the graph on the left. So that boundary separates between the red and the blue. And I try to generate that boundary using only the large data without having access to the small data. Now, if you look closely at the boundary, it does not exactly separate the blue from the red. There's some blue that are above the boundary and some red that are below the boundary. So machine learning tries to find the best boundary between the two categories. Now, if you look on the right, there's another graph, and that has not just two categories, but several categories. But the idea is the same. Machine learning is used to create regions in which each region corresponds to one class. Now, these are very simple examples, but any type of classification, machine learning works like this. Based on data characteristics, in this case length and weight, we try to make a separation between different classes. The inputs are the weight and length data. The output is the class number. Okay? Now this is an example of supervised machine learning. Here's an example of unsupervised machine learning. We have some data. Again, the large data is the data that's available. The small group blue points are the individuals in the population that I do not have their data. And I use the data from the large points to try to infer different clusters or different groups of individuals who are close together. Here I have 3 clusters in this case, which I've labeled 0, 1, or 2. But notice in this case I don't have different colors. I really don't know the different categories for these individuals. I've just inferred a separation between them, which may be useful in order to describe the differences between individuals in the population. Okay? So that's unsupervised learning. Now, there are many different machine learning methods which create functions with different characteristics. You may have heard of some of these methods. Here you can see at the beginning there's tree-based methods. Random forest, for instance, DT is decision tree. And these build functions based on decision trees, which are binary 0-1 decisions, a series of decisions. There's support vector machine, SVM, which generates a boundary function that divides the function domain into regions. There's KNN, logistic regression, and there's also deep learning having to do with neural networks of various types. Now, all of these different methods are doing the same thing in different ways. They're all trying to generate functions that distinguish between data categories or that attach a number to different data points. But in every case, they're trying to create a function. Okay. What machine learning can and cannot do? Machine learning can imitate human behavior. It can perform recognition tasks like recognize people from images. It can react. It can generate text that seems like it comes from a human being. They can respond. You can have chatbots that talk with human beings so they can imitate human behavior. They can solve puzzles and games. The best chess player in the world right now is a computer using machine learning. And they can find patterns in data that humans cannot immediately see. On the other hand, machine learning cannot find patterns in random data. If you give machine learning a lot of data, that does not mean it will do a better prediction. If the data does not contain the information you're looking for, machine learning can do nothing. Machine cannot get good results from bad data, and it cannot tell fortunes, as you see in the picture on the lower left. Machine learning cannot tell you who you're going to marry or when you're going to die. Machine learning extracts information, it does not create information. Now, it's important to use the right machine learning method for the job. Here we have 2 different types of hammers. On the left, you see what we call a jackhammer, and it is used to drive in very large objects called piles. And you can see it's a very powerful hammer, and it is created for very big objects. On the right, you see a woman using another hammer to hammer a nail into the wall. Now, both of these instruments are hammers, but they're not both useful for the same job. You do not use a huge jackhammer to hammer in a picture. You use the small hammer. So when you're using machine learning, start with a job and then choose the method according to the job. Don't choose the method first. Now, the good news is that the computer language Python contains many of these different so-called hammers. Python has several libraries. One is called scikit-learn, and scikit-learn has many classical machine learning options, and I'll explain what I mean by classical. And Keras and Torch are used for deep learning. Well, I can say that classical machine learning are the simpler methods, such as logistic regression, support vector machine, and so on. And we really divide machine learning into classical machine learning and deep learning. Deep learning is large, deep neural networks of various types. So, for instance, you do not use deep learning when you have a limited amount of data. It's not going to give you a good result. And you don't use classical machine learning when you have something like images that have very complex information that needs a lot of parameters and a more sophisticated model to characterize the different images. So, as I mentioned, in the Python computer language, there are many capabilities, including both classical machine learning, which are the basic machine learning models, and deep learning. So I just want to give you some of these online resources for learning Python, and I can distribute this presentation so you can have these links. There are many opportunities online to learn Python, and you do need to learn Python well in order to apply machine learning well. Most machine learning in industry is implemented using Python. So there are some good Python coding practices. You want to vectorize your code. You use arrays and array operations instead of loops. You do not use loops very much if you want efficient code. You modularize your code and break it up into functions. You object-orient your code by using data structures such as classes and dictionaries. And I give a reference below to all of these different concepts. Two Python platforms you can use. One is Anaconda, which you can install from the given website. It includes both Jupyter Notebook and Spider. These are two very common user interfaces for Python. It can be used in Windows, Linux, and Macintosh. Sometimes it can be slow. There are alternatives, Visual Studio and PyCharm. There's also a web-based platform called Google Colab, and you run this directly from Google Drive. And this is a very nice feature from Google. Let me see if I can show you briefly. I'll open up my browser. I can get my mouse. And let's try this. If I just go to my Google Drive, you would need a Google Drive account. You go here to New, and then let's see, it should be, I can go down to More, and I should be able to get to a Google Colaboratory right here. Right. Now this is actually like a Jupyter Notebook, and I can put code in here and I can execute it. 5 plus 3, run it, and it will give me, well, it's taking a minute to initialize. It gives me 8. Right? So this is running code. I can do anything I can do in Jupyter Notebooks. So this is a very nice feature. It can also do parallel processing if you change the runtime type to a hardware accelerator. I can use graphics processing units. Now, this is a very nice computing platform. So if you don't know about this, I encourage you to explore this feature. All right. So there are many resources for machine learning. Again, I will make this presentation available to you. The best way to learn Python is go online and learn for yourself. Now, let's get to the main question is, how do you find or how do you create an application for machine learning? So here are some prerequisites. You need to have these conditions in order to have a machine learning application. You need to find a situation where classification, prediction, or clustering is needed. And the best way to do this is talk with people who are in other areas. Understand their way of thinking and their terminology. Then you can understand their needs. For instance, you're part of a university, Al-Zam Al-Azhar University. There are many other departments that have data, including the medical sciences, engineering, ecology, biology, and so on. And these people have data that need to be analyzed. So you have the tools as a computer scientist to apply machine learning to this data. Now, it takes some time to understand their way of thinking and their terminology. But once you do, you can apply machine learning to solve their problems and use their data effectively. One of the main obstacles to using machine learning is having sufficient data. So really, that's the first thing you need to get, is get enough data, and the data has to be labeled. If you want to use machine learning to categorize, you need to have some data that's already categorized. For instance, if you want to classify images between dog and cat, you need some images already of dogs and cats that are classified. Okay? So you need some data that's labeled if you're trying to classify or predict, or if you're only trying to cluster, you use unlabeled data. You don't need to have a characterization of the data that you have. Then you also need to decide on a suitable machine learning method, and always you should follow the rule, simpler is better. A good way to proceed is try a simple method and then try a more complicated method and compare the results. Often the simpler method will perform better. All right. Here's some examples of machine learning applications. I'll go to this website and you will find hacks here. If you look on hacks, some of these actually come from published research done by master's students. Galaxy classification. In Africa now there is a radio telescope with lots of data, and machine learning can be used to classify different types of galaxies. And this is published research. Apple classification. Now cameras can be used to automatically classify apples according to quality. Rooibos tea classification. Again, you can use chemical data from rooibos to classify rooibos into different types. Rooibos is a tea from South Africa. You also have sentiment analysis, which looks at Twitter and decides whether people have a positive or a negative opinion of something. That's a very common application. But these are some examples of master's level research that is published that is possible for a student to do as a stepping stone to their career. And I can show you briefly some of the publication here. If I go to here. You can see some of these applications. These are some papers I wrote with master's student Eslam Hussein. Groundwater prediction, so this is weather prediction, and that's one application of machine learning. All right. Here's the Rooibos research, and then here's the Apple research, and these are published papers. All right, so let's go back to our show, and we continue. And I want to emphasize that you have opportunities at your university to talk with people from other departments, and many of them have data that needs to be analyzed. I know that people in the ecology department and medical department have survey data that needs to be analyzed, and they need the analysis to be automated. And that's something that you as computer scientists can do. All right. Now, if you want more summary information, I have this link here that has several resources. If you go here and you look at the folder called Thrawn here, you can look at all the resources in this link. I have several things here. If you want to go further and find applications, you can go in the folder called Applications. There's also this folder called PowerPoint, and this presentation is included in that folder called PowerPoint. So let me give you the URL again. Here's the URL again, tinyurl.com/ML for Africa. Okay, so you can get many resources here. And let's look at this applications. And you can find many different examples. For instance, here's business applications. We can look here. And they give some different applications. This may take a minute. While it's doing this, let me go. Oh, here we are. Okay. So it's converting the PowerPoint. All right. So here they'll introduce some different applications. So one thing, infrastructure. Infrastructure means, for instance, communication, networks, different structures that are used to get the job done. One big application of machine learning is cybersecurity. You want to develop a strategy against intruders, and you want to recognize patterns of intrusion. So machine learning is good at classifying access data to try to determine whether a certain IP address is trying to infiltrate a system. That's another example of application. I would say that three main areas of machine learning that are very useful now are the business, healthcare, and education. And you can find several examples of these three applications in the resources that I've put in this folder. So you can look at this big book of machine learning use cases that also can be useful. So, and these give some specific examples of different applications. Okay, for instance, here's so here this is for playing baseball, which is an American game, and they actually apply machine learning to games. You can apply machine learning to football and decide what players are best for your team, decide what strategy is best to use against another team, and so on. Because you have past data of past games, and you can use machine learning to analyze this data. Okay. And here we have out-of-stock modeling. So this is trying to model the demand for certain products and see if you can predict when you're going to go out of stock so that you can always have available product when people need it. Here's time warping. I'd have to read this to find out what this is. Detecting fraud. So again, this will look at access data or credit card transaction data and try to determine whether someone is using their credit card wrongly. Okay. And a time series forecasting. I showed before some applications of machine learning to weather prediction. That relates to time series. Image classification using PyTorch, geospatial data, Twitter sentiment analysis, and so on. So there are many different options for applications. I also have this one here that I can show briefly. Let's see, where is it? I guess it's here. All right, so let's close this and go back. This one also lists several different applications. I also have the table of contents from 2 different books that I edited, and these also contain examples of master's level research. So I think I'll stop here. You have these resources to look at if you want to know more about the capabilities of machine learning. But I will say that machine learning is now widely used in business, in healthcare or medicine, and in education. So there are many opportunities in these fields for you to make a contribution as a machine learning researcher. All right, thank you very much.